Okay, hi everyone. So this will be our first lesson on Pure Maths 3. So the chapter 1 is called as Algebra. So actually there are a lot of area, there are quite a number of learning outcome that you need to achieve after this chapter. But then yeah, because of your semester 1 exam and so on, so I think before that we are just going to cover one part, which is about modulus function. Okay, so the focus about these two lessons is only one thing, which is called as modulus. Alright, so I think a lot of you already know that what does that mean by modulus is basically like something like this. Okay, alright, so what are you going to learn after these two lessons is that you will understand what is the meaning of modulus. Then after that you should know how to use some relationship, or either use the method in algebra or like using graphing way to solve an equation or like inequality in modulus function. Then after that we are going to learn also how to draw a graph for a modulus. Basically the modulus function is a linear function only. Okay, so those are the things that you are going to cover after these two lessons. So we are going to like separate this learning outcome into like two lessons. So in the first lesson we'll be cover the part that how to solve modulus equation. Then for the second video it will be about how to solve how to solve modulus inequality. Alright, so let's start with a very quick introduction about what modulus function is first. Okay, so you can look at your notes here. So the modulus of a number is the magnitude of that number. Okay, what does that mean? The idea of here, what is important is the word of magnitude. Okay, what does that mean by magnitude? So let me try to explain it in an easier way. Okay, let's say magnitude meaning that the number only indicate the size but not the direction. Okay, so for example, let's say I have this number line. So this is 0. So I have here -2 and I have the other 2 here. Okay, what does that mean by modulus? This is modulus. So meaning that if I am talking about the distance without indicate or without knowing that whether it's on the negative side or the positive side, I only want to find how far the value from the 0. These are all magnitude. So for example, from 0 to -2. So the -2 here indicate the direction, meaning it's on my left hand side of the center point. So that's why we try to put negative, right? So when we want to find magnitude, meaning that we want to indicate the size only. So what is modulus -2? It's basically 2. So the distance is 2 units away from 0. So it's the same thing if I have something that is like +2. The positive here indicate that it's on my right hand side. So if I want to find the magnitude, the same thing, what is the distance from the 2 from the center point is basically 2. Okay, so when we talk about magnitude, right, then you know that anything with a modulus sign, no matter it's positive or negative, you are going to get a positive number. Meaning that you only want to know how the size is, how the magnitude is without taking note of the direction. Okay, so meaning that we are not talking about vector, we are talking about only magnitude. So this is what does that mean by modulus. Okay, so sometimes the modulus of a number is also called as absolute value. Okay, so let's try to do some definition. Okay, so the definition of modulus, when we try to write it in a more appropriate way in mathematics, then what does that mean? Okay, so when you have modulus, right, let's say if you have something like just now 2, anything that is positive in a modulus, when you want to come out, when you want to solve it, right, after you solve it, you get the exactly same number. like modulus 2 will equals to 2. So meaning modulus x will equals to x if your x is positive. So meaning that any number within your modulus is positive, then you will be writing the exactly same number after you solve the modulus. Okay, now move on to the other one. Let's say negative 2. So what did you actually did to negative 2 so that it will become 2? Is that you negative the negative number, correct? So negative become positive. So modulus x will be equals to negative x if the x is a negative number. Okay, so in an easier way, let's say if I have modulus 5. So since it's a negative number, so since it's positive here, so when I solve it after modulus, then I'll be getting exactly 5. So meaning x will be equals to x if it's positive. So if it's negative 5, then what you need to do, if the x is negative, so meaning now your x is a negative number, right? Then what you will do negative 5, which brings you equals to 5. Okay, so I think those are the things that you actually know already. Okay, so the other thing is we can try to use square root or like square to indicate the modulus. Okay, so let's say x will be equals to square root x squared. Okay, what does that mean? Let's try it out with the 5 as well. Okay, so modulus 5 will be equals to square root 5 squared. So you see square root 5 squared, then I get 25. So 5 squared, I get 25. After square root, then I get exactly 5. Okay, why is that? So that we can put inside. So you still remember the real definition of square root in mathematics is basically a positive one. So anything that you did after square root, you should able to get a positive number only. Okay, except like the case that you have positive and negative outside. But when we talk about the definition, then we talk about positive only. So it's the same thing if I have negative 5. So what does that mean? I can put it inside the square root, negative 5 squared. So negative 5 squared, I get 25. So after I do square root, then same thing, I'll get a 5 as well. Okay, so those are the things that will be helpful for us when we want to solve the equation later. Okay, the other thing that I want to talk about is about the graph. Okay, so that part is like quite an easy one also. I think we discussed a little bit about that when we learn transformation in Pure Maths 1. Okay. So how is the graph for a modulus function look like? Okay, so you can imagine, let's say I have a graph of y equals to x minus 1, let's say. Okay, so let's try to do an easier one. So meaning that if your x is 0, then your y will be negative 1. If your y is 0, meaning your y-intercept, then your x-intercept, then it will be equals to 1. Okay, so if you try to draw this, right, then you will get something like this. Okay, so here is x, y. Okay, so you have when y is 0, your x is 1. Then when x is 0, it's negative 1. Okay, so this is your original graph. Okay, what happens if I want to draw a modulus graph? So you can see that what happened is I have this graph, right? So you know that anything after you solve with a modulus, you should able to get only positive number. So what does that mean? Meaning all the part that is below your x-axis will be irrelevant because you will never get a negative number after you did the modulus, right? So this is why what happened is that anything for x minus 1, okay, for x minus 1 lesser than 0, meaning if it's negative, what will happen? You will need to do negative x minus 1. So it's the same thing like what we have learned in transformation, that you will actually do the reflection at the x-axis. So meaning that how it will look like. So instead of like drawing it like this, okay, let me try to draw the dotted line. Okay, so this is your graph, right? So the part that is negative will be reflected. So meaning instead of like a -1 here, it will become 1 here. Alright? Yeah, because it's going to be the same thing like if I get negative 0.5 here, then I should be able to get 0.5 after I did modulus. So if I get -1 here, then I should be able to get 1 after I did the modulus. Okay, so that's the idea. So you remember every graph of your, so we are talking about only linear function. So meaning like you only have like y equals to ax plus b, something like this. So all the graph that is in linear, you know that it should be in a straight line, and every line that you did with a modulus, then it will create a reflection. So normally for all the graph for a modulus function, right, you will see something like a V shape, because it's definitely going to be reflection for the part that your y is lesser than 0, which is when the thing in your modulus is negative, then it's going to be reflection. Okay, so we are going to use some knowledge that we've gone through here, then after that we'll put it into like some question. Okay, so this will be your question. Yeah, so I didn't try to do it like the statistic part, like putting all the empty space here, because I think it's like we waste a lot of paper if you do like that. So I think what you can do is either you print out then you do it together, or like even you can just refer to your computer and you try to copy it out, since like the question is like very short for pure maths. Okay, so let's try to see question 1a. Okay, so 1a, solve the following equation. So 1a, modulus 2x minus 1 equals to 3. Okay, so how do you solve that? So you know that for modulus 2x minus 1 equals to 3, meaning that what happened for 2x minus 1, it can be a -3 and it can be a +3. So meaning that what you can try to do is 2x minus 1 equals to 3. Then definitely you know that if 2x minus 1 equals to 3, after you did the modulus, then you get 3, right? So the other one is 2x minus 1 will be equals to -3. So what is that -3? So you know that if 2x minus 1 is -3, after you did the modulus, then it will be equals to 3 as well. So this is how you get these two. So it's the same thing if you want to do the definition part, meaning that you know that this can be a negative, can be a positive. When 2x minus 1 is either positive or negative, you can do the same thing as well. So it's the same idea if I say that if I say that x equals to +3 or -3, or I say that -x equals to 3 or +x equals to 3. So they means the same. Alright, so but we just go to the easier approach that we try to figure it out, like what is the answer inside a modulus that can give me 3. So of course it will be like either 2x minus 1 is equals to 3 or 2x minus 1 equals to -3. Okay, then after that we can try to solve it. So 2x will be equals to 4, so x will be equals to 2. So 2x will be equals to -2 and x will be equals to -1. Okay, so something that is very important when you solve a modulus function is you must make sure that you must fit your answer back to the original equation after you did everything. So meaning that, check. Okay, so 2x, so you can substitute 2 minus 1 equals to 3. So you just substitute and you check. So 2 times 2 you get 4, 4 minus 1, 3 modulus, then you get 3. So this is a true one. Okay, so the other one, 2 -1 minus 1 equals to 3. Then you check again. So -2 minus 1 you get -3. After modulus you get 3. So this is true as well. So after you check, then only you can say that the answer is x equals to -1 or x equals to 2. Okay, so this is what you need to do. Alright, so later I will show you like one example that how why is that a need for you to like substitute back in. So we will try to do one question that is like there is a false statement there. Okay, So when you want to do this, then I'll show you the other way, like how to use a graphical way to do this as well. Okay, let's say, yeah, because I do not want to like split it into like so many questions and so many parts, so we are going to discuss it together, so it will be like much more easier for us. Okay, so let's say if I have this question, how am I going to draw the graph? Okay, so you know that for intersection, right, if I talk about simultaneous equation, then normally we use simultaneous equation to help us to solve like the intersection part, and those are my solution. So meaning that, sorry, this is the algebra part. Okay, so I'm going to show you one more. This is how to use your graph. Okay, so for you to use your graph, right, meaning that what you need to do, you need to solve it like a simultaneous equation. So I will have, so this is my equation. So meaning that what I will have is I will have two graphs here. The first one is the modulus part, meaning the left hand side. Then after that, I have the other one, y equals to 3. Okay, so this is my two simultaneous equation, and I'm going to draw it in the graph so that I can see the intersection, and those are basically my answer. Okay, so how am I going to do that? So when you want to draw the graph, it depends on whether you want to straight away find 3 points and you draw the V shape, or the other one will be like much more easier, is you find the part that is like going to reflect. So you know that it's going to be reflect at the x-axis. So you can straight away do y equals 0, then what is that number? Okay, so let's try to do that. Okay, so for the graph, y equals to 2x minus 1. Okay, then what you need to do, so maybe you want to find few points here. So you know that the intercept will be, so let's try to do the reflection first maybe. Okay, so y will be equals to 2x minus 1. So when x equals to 0, then you get y equals to -1. And if you have like y equals to 0, then you have x equals to 1/2. So let's try to do one more. When x equals to 4, then y equals to 3. Okay, so after that, let's try to do it on the grid paper. So it's the same thing. If you don't want to print it out, it's totally fine. You can just use your notes or your foolscap paper to draw it. Okay, so I'm going to show you roughly here. Okay, so let's say I have this grid. I'm just going to show you like 1 or 2 questions, because I think like the drawing graph part, it should be alright for you. So I'm just going to show you like some of the questions lah, so not every. Okay, so let's say I have something like x equals to 0 and y equals to -1. So it will be like here, the place that is -1. Then y equals to 4, sorry, x equals to 4, y equals to 3. So it will be somewhere here. Okay, so y equals to 0, which one? Y equals to here, so it will be like somewhere here. Okay, 1/2. So I will try to do the 1, 2, 3, 4. X equals to, oh sorry, I did it wrong. X equals to 2 and then y equals to 3. Yeah, so it should be here. Okay, so I'm going to draw the line. So since you know that it's a modulus, so maybe what you can try to do is, this is the part that is going to be reflected lah, so you do not really need to draw it up. So what you can see is, after that you need to do a reflection. So it's the same thing. So you know that like you can use some of the part to help you to do that. So for example, you know that it's going to, if I'm going to draw it, if I'm going to continue to draw that, right? Okay, then what I'll be able to get is like a reflection of the line. So this part, instead of -1, then I'll be getting 1 here. Okay, so it's like a proportional one. So if this is -1, then it's going to be 1. If this is -5, then it's going to be 5 up there lah. So after that, you are going to do a reflection on the x-axis here. Okay, so this is the graph that you should be getting. Alright, Okay, so after that, what you need to do is the next one. So after you draw the graph, right, then you can continue with your second one, which is y equals to 3. Okay, then I will try to draw the other line. So this is my y equals to modulus 2x minus 1. Then after that, I will draw the other line here. Okay, to draw a graph that is y equals to 3. So it will be like 1, 2, 3 over here. Then you can draw your line. Okay, so this is basically y equals to 3. Okay, so your answer will be the intersection point. So meaning it will be 1 here and 1 here. Okay, so what is the number for your x? Then you can try to drop it down. Okay, so this is basically -1. Then here is basically 2. Okay, so from the graphical way, you can see that you get exactly the same answer like this also, which is x equals to -1 and x equals to 2. Okay, so the other way of drawing the graph will be, what you can try to do is you try to do the definition also is alright. So meaning that instead of like doing like finding the points here, right? So it's the same thing that I mean you still need to find the point, but then the different approach is what you can try to do is modulus 2x minus 1. There will be like two cases. The first one is you will have the exactly positive, meaning the original number. What if your x is greater than 1 over 2? So meaning that when you try to put 1 over 2 here, you get 0. So anything that is greater than 1 over 2 will give you a positive answer. So the other one is you will get a -1. Okay, you will get a negative if your x is lesser than 1 over 2. So meaning that if you plug anything that is like lesser than 1 over 2 here, you will need to do a negative for the modulus part. Then you try to draw these two graphs. Okay, so it's the same idea. So maybe you try to do this for the other question. Okay, alright, so now let's continue with the next one. Okay, so for number 2, so I have modulus x minus 4 equals to 2x plus 1. Alright, so it's the same thing, so let's try to do it. So x minus 4 equals to 2x plus 1. Okay, so you remember it's just going to be the same thing. You know that what happened inside the modulus, it can be negative or positive. As long as after you solve the modulus, then this is how you get a positive number after that. Okay, so meaning that it can be x minus 4 equals to 2x plus 1, or the other one is x minus 4 equals to negative 2x plus 1. Okay, so I repeat again, it's the same thing if you want to write it in the way that x minus 4 equals to 2x plus 1, or negative x minus 4 equals to 2x plus 1. Okay, because like x equals to 3, so the idea is like if I have something that is, okay, maybe I write it here. If I have like modulus x equals to 3, so you know that the modulus here, it can be represent x or it can represent negative x, correct? So this is why you can write like x equals to 3 or x equals to -3, or you want to write x equals to 3, -3, negative x equals to 3. They just mean the same thing. Okay, so you can solve either one, but normally we try to do it at the back because it will be easier for us to solve it, but no worry, you get the exactly same answer as well. Okay, so maybe you just continue here. So 2x, then you get x will be equals to here -5, and then after that negative x plus 4 equals to 2x plus 1. So 3x will be equals to 3. Okay, so x will be equals to 1. Alright, so after you get the answer, same thing, you will need to try to do the checking. Okay, so x equals to 95 first. So you can just plug it in. Okay, so what you can realize here, -5 minus 4, you get -9. So after you did the modulus, you should be able to get a +9. But what happened here, you check. 2 times negative 5, you get negative 10. So negative 10 plus 1, you get negative 9. So this is a false statement. Okay, so you can see that although you get a negative 5, but then the answer is actually not negative 5. Okay, I will show you why later. Okay, so now let's say you have, let's try to check the other one first. 1 minus 4 equals to 2, and then 1 plus 1. Okay, so you check 1 minus 4, you get negative 3, so modulus, then you get 3. Then 2 plus 1, you get 3, so this is true. So meaning that what happened for this solution, you only have one solution, which is x equals to 1. Okay, so now let me try to show you why is that wrong. So this is like an explanation part, so if you can't understand, it's totally fine as well. So you just make sure that every time after you do the after you did the solving part, you need to check your answer. So that's the point. Okay, so let me try to explain it in this way. So you remember how this come from? So when we talk about the definition, right, you still remember, so meaning like I have x minus 4. Okay, it will be the exactly same thing if what happened inside the modulus is positive, right? So meaning that if x minus 4 is positive, what does that mean? If x is greater than 4. So for this part, it's going to be like negative x minus 4. It's like the same thing, like if I want to do modulus negative 2, then you will do negative 2, so it become positive. So this is the idea. If what is inside the modulus is a negative 1, so meaning x smaller than 4. Okay, so this is the constraint that we actually need to take into the consideration when we try to solve. But then you see, when you check back your solution, right, when I only start to do this part where is x minus 4, actually I do not really know that whether my x is greater than I do not actually know that whether x minus 4 is a positive or a negative yet. So you see, the problem with this is this. So if I have this, so let's see the correct one. Okay, so this is the correct one when x equals to 1. So x equals to 1 actually drop under this, correct? So meaning the x is smaller than 4. So this is how you get x equals to 1. So when you do negative x minus 4, it's correct because by definition it's correct, right? So you see, this is what we do, so that's why you got a correct answer. But then you see, this answer is x equals to negative 5. Supposingly, it is under this category as well because x smaller than 4 include x equals to negative 5, right? So what you need to do, actually it should be this. But then you see, how do we get the answer is from x minus 4. Why is that happen? Because we only do an assumption that it can be positive, it can be negative. But then the problem is when we solve this, because of we do not know what is the x, so we do not really know that whether it's positive or negative. So we cannot decide that whether it will go to this way or we will go to this way. But after we do this, then only we try to consider the constraint of like, I really need to check it back, like whether I will get a positive number or a negative number. Meaning that what happened is at first we try to ignore what is that happen when x equals to 4. We try to ignore the possibility whether it's positive or negative. We just do an assumption. So we try to hold the part of the checking until the end when we got the solution. Because by having the x, then only I know that whether it's true or false. Because if you do not know the x, how are you going to know x minus 4 is positive or negative? Then you do not know that whether you need to go to this way or this way. Okay, so that's the idea. So you see, if we try to put it back, right, then what you can realize is like x, so negative 5 minus 4 equals to 2, negative 5 plus 1. So this is how it got wrong, right? So you see, this is negative 9, then this is negative 9. So you can realize here is that if modulus negative 9 is negative 9, then this statement will become correct already. Because if negative 9, then if I go to this direction, meaning that I assume that what happened inside is like a positive, then I'm not going to change it anywhere, then I will get the same answer. But the problem is because of it's a negative number, so when I solve the modulus, then it will become a positive one. So this is why is that making this statement become a false one. So that's why every time when you want to solve the equation, you must make sure that you must check at the end of your answer. Okay, so maybe let's try to do this in the graph as well, so you can like see the idea. Okay, so the same question. Okay, so let's try to draw it in the graph. So this is the last one that we will show in the graph. Then after that, the other one you can try it yourself, because I think that the video will be like so long if I show the graph here. Okay, so the same thing. So maybe since we already did the definition, let's try to use the definition part to do this. Okay, so I'll be writing here, like it will be much more easier. I do not have enough space here. Okay, so so you will be need to draw y equals to modulus x minus 4. Then the other one that you need to draw is y equals to 2x plus 1. Okay, so let's start with the modulus first. So since we use a definition, so maybe we can use a definition to draw this. So x minus 4, you will have two approach here. So the first one is, it will be the exactly same thing. If x is, so we just use whatever that we get just now lah. Okay, if x is greater or equal than 4. So this is how 4 minus 4 you get 0. So anything that is greater, like 5 minus 4, then you get a positive. So after you do the modulus, it's still the same number. So you will get a negative 1. Okay, so if your x is lesser than 4. Okay, so we try to use this to solve. So meaning that I will have like two lines here when it's like x smaller than 4 or x is greater than 4. So you know that this is the critical value that your graph will be reflected. Okay, so I'm going to like show it roughly here. So 1, 2, 3, 4. Maybe I'll draw it somewhere here. Okay, so x equals to 4. So meaning that you know that this 4 is the part that they reflect. Okay, so for the part that is x greater than 4, meaning anything that is on the right hand side of the 4, it will be a graph of x minus 4. So meaning x minus 4 is here. Okay, so no, I mean the y-intercept is here. So you are going to draw the graph. Okay, then after that, oh sorry, yeah, I mean this is too long. Then after that, I should actually draw the dotted line here. Okay, it's fine. So then after that, I'll continue with this part. So after you do it, then you should get a negative 4 plus 4. Okay, so you know that the intercept will be at 4. So you can realize that it's actually a reflection happen here. So like for anything, any point that has a x smaller than 4, I will have a line of the equation negative x plus 4. So this is how I draw the other line. Okay, so this is basically my graph of x equals to modulus x minus 4. Sorry, this part it should be I just do this lah. Okay, so this should be the dotted line part. So this is not a part under the modulus. Okay, so now how do we solve it? Then we need to draw the other line, right? So y equals to 2x plus 1. So you have an intercept for 1, which is like here. Okay, then after that, let's try to do the other point. Maybe x equals to 2, and then y will be equals to 5. So x equals to 2, y is 5, so it's like somewhere over here. Okay, then you try to draw the line as well. Alright, so what you can realize, this is the only intersecting point. So this proves that our answer, you only have x equals to 1. And what can you realize? The x equals to negative 5, what is that happen? Yeah, it's going to happen if you continue to draw this line. If you continue to extend this line, then most probably they will try to intersect with each other at -5. But because of we did a reflection, so that's why this solution is gone. Okay, because you see what you do here is that you assume that it's positive, so that's why you try to ignore the modulus part, so this is how you get the negative. So it is correct if I did not do a modulus for a negative part here, so meaning if without reflection, then most likely they will be like intersecting with each other at the -5 part. Okay, alright, so let's move on to the next one. Okay, so number C, so we are just going to do it in an algebra way, so you can try it with the graph by yourself. Okay, so I believe it's the same thing, so you definitely can do it also. Okay, so if you get something like this, so make sure that if you have one modulus only, so make sure that you try to you try to solve the equation until you only get a modulus at one side. So meaning that please do not try to do this equals to 16 and this equals to -16. So that's totally wrong. So what do you need to do is you need to shift the other information that you don't want to the other side. So this is how you left with modulus at one side. Okay, so 3 modulus 4x minus 1 will be equals to, so -5, then you get 21 here. So modulus 4x minus 1 will be equals to 7. Okay, so after you get modulus at one side, then you can try to continue. So 4x minus 1 equals to 7, or 4x minus 1 equals to -7. Alright, so 4x will be equals to 8, so x will be equals to 2. Then 4x will be equals to -6, so x will be equals to -3/2. Alright, so after you do this, the same thing, so make sure that you try to check again your answer. So check. Okay, so substitute back into the original equation. So just copy and substitute your x with 2 that you found. Okay, so this part you can actually use your calculator to do it, like 8 minus 1, 7, 7, 21, 21 minus, then you get 2. Okay, so the same thing, 3, 4 times -3/2 minus 1 minus 5. Okay, so you'll be getting -6, then after you do modulus, then same thing, you get 7 and 16, so this is true as well. Okay, so you have two solutions here, which is x equals to 2 and x equals to -3/2. So it's the same thing if you need to draw your graph, right? It's either you solve it up to this point, then you draw a graph of y equals to modulus 4x minus 1, and the other graph is y equals to 7. Or if you want to do some challenging part, then what you can try to do, you can start at the first. I mean, of course, you can try to do, you learn transformation before, right? You know how's the graph of 4x minus 1 look like in a modulus, then you do your stretching, then you do your translation. So it's going to be the same thing as well. But since that that is not like required in this case, so you can just try it at your own. You should be able to get exactly same answer as well. Alright, so let's go to D. So for D, modulus 2x plus 1 divided by x minus 2 will be equals to 5. Okay, so this is the same thing. So what we need to do, you just solve the modulus first. So either 2x plus 1 divided by x minus 2 will be getting a +5, or 2x plus 1 divided by x minus 2, you will get a -5. Okay, so 2x plus 1 equals to 5x minus 10. So -3x will be equals to -11. So x equals to 11/3. So 2x plus 1 equals to -5x plus 10. 7x equals to 9. X equals to 9/7. Okay, so the same thing, you do the checking part. Substitute. Okay, so I'll skip this part, like I already used calculator to solve it, so you just make sure that you go through the process again by yourself. So 2, 9 over 7 plus 1, 9 over 7 minus 2, so you should be able to get 5 as well, so this is true. So you have two answers here, which is x equals to 11 over 3 and 9 over 7. Okay, alright, so D. Let's go to second question. Okay, so E, what can you do if you have both side modulus? Okay, so let's try with the approach that we did all this while first. Okay, so let's say you know that, like for example, if I have square root modulus A equals to modulus B, what does that mean? You will have four different kind of scenario here. The first one, it can be A equals to B, correct? Meaning that both inside the modulus is actually a positive number. Or I can have both inside the modulus is a negative number. So after I did the modulus, then the negative gone. I will have the other part, which is maybe only B is negative, and the other part is only A is negative. So since you have four different probability that will happen here, but after that when you solve it, what can you realize? These two bring you the same outcome, which is A equals to B. Because negative A equals to negative B is going to eliminate cancel off the negative sign for both sides. So the same thing for this one. So it's the same thing when I say x equals to 3 or negative x equals to 3. So, sorry, when I say x equals to negative 3 and negative x equals to 3. So that's why this is going to be the same as well. So that's why if you have both sides, then what you need to do, you do the exactly same idea, but you just make sure that the modulus is like for both sides lah. Okay, so 3x plus 4 equals to x plus 5. Or the other one, 3x plus 4 will be equals to negative x plus 5. So same thing, I'll continue to solve it. 2x equals to 1, x equals to 1 over 2. So this one minus, then I have 4x equals to negative 9. So x will be equals to negative 9 over 4. Okay, so same thing, you need to do your checking. So 1 over 2 plus 4, then equals to 1 over 2 plus 5. Okay, so here you get 1.5, so 5.5, so it's true. The same thing, 3 negative 9 over 4 plus 5, okay, equals to negative 9 over 4 plus 5. So this is the same thing, I will actually get the answer as well. Okay, so you just continue to do that. So checking, okay, do you have the other way to do that? Yes. Okay, so I'll show you that one. So this is method 2. Oops. Okay, so you have modulus 3x plus 4 equals to modulus x plus 5. So you remember just now we said that when we talk about modulus, we can write it in this way. Okay, so we are going to use this method to solve it. So meaning that if I have something that is modulus A equals to modulus B, what can I do? I can actually put it in A squared equals to square root B squared. So A squared will be equals to B squared. Okay, so you remember that for anything, for any equation that you have both side modulus, then you can always do squaring. But you must make sure that it's like for the both side modulus, meaning that both side you are getting a positive number, then you only can use this method. So the idea is, let me show you why is that wrong if you want to do the other way. Okay, let me think of an example. Okay, let's say x equals to negative 3. Okay, so if I try to do the modulus, then you know that I'm going to get 3, right? So, but if I'm going to put it inside, let's say I want to find x squared here, so x negative 3 square, then what I get, I'll be getting 3. So what I am trying to do here is like x squared. So my question is, if I'm going to compare to this, then I know that this is definitely giving me a 3. So if I say that x equals to 3, is that mean that my x is okay, let me try to write it like this. Okay, you cannot do that if this is not in a modulus, because the idea is after you try to put it inside, right, you are eliminate the idea that it's going to be a negative number, because this is how you get 9 and equals to 3. But you see, there's no problem, right? X will be equals to square root x squared. So I substitute my x, which is negative 3 here. But then when I try to solve, then I get x equals to 3. Is x equals to 3? No, x is actually negative 3. But then because of we substitute it inside, and because of we do the square root, so that's why we eliminate the chances of it getting a negative. So that's why you see x equals to negative 3 and x equals to 3 is totally different story. So that's why you only can use this method when you have both side modulus, meaning that you have both side positive answer. Then you can only use this method. Okay, so what you can try to do, just do the square. 3x plus 4 equals to modulus x plus 5. Okay, so that's why 3x plus 4 square equals to x plus 5 square. Then you continue to solve it. 9x squared plus 24x plus 16 equals to x squared plus 10x plus 25. So 8x squared plus 14x, then after that here minus 9 equals to 0. Okay, then you solve by factorization. 4x minus plus, oh yeah, it should be plus 2x minus 1 equals to 0. So this is how you get x equals to negative 9 over 4 and 1 over 2, which is basically the same answer. Okay, so I'm not going to do the checking again since we did it already. So this is the answer that you get. Okay, so I repeat again, you only can use this method when you have both sides that you already confirm is going to be positive. Okay, so your question might be, how about the question that we did previously? Can we use square? Okay, I would say I don't encourage you to do that, but in terms of mathematics, you can do that. So for example, some of the question like if you have D, okay, this question, can you do squaring? Yes, because you know that 5 is a positive number. So if you want to do squaring, yes, you can go ahead and try it. Okay, so how about C? So this, can you try to do square? I mean, of course, if starting from here, then you wouldn't want to do square because it's very hard for you to square the whole thing here. But if you solve it up to this point, then yes, you can, because you know that 7 is definitely a positive number. So it's fine if you want to do square as well. So you can try this out also. Okay, for B, for this question, you cannot do that. Why is that so? Because 2x plus 1, you do not know what is your x, so it can be a negative answer here. So when you try to square it, then you are eliminate the chances for you to continue to get a negative number. So that's why you cannot do that. So for your number 1, which you try to solve with 3, yeah, this one you can do square also because you already know that 3 is a positive number. But then I will encourage you like to not to risk that part. So for any simple question like this, you just try to go through the way that it's going to be one negative, one positive. Then for the question that you have both side modulus, like this one, then you only do the squaring. Okay? Alright, so let's move on for the very last questions. Okay, so we have x plus 3 plus x plus 5 equals to 10. Okay, so let's try to think of it. can you try to use square to do this question? Okay, I mean, of course, you wouldn't want to start from the beginning, right? It's like very hard for you to actually want to square this part. Okay, so maybe you will want to try to change it to easier way first. Okay, so let's try to change it around. So I have x plus 3 equals to 10 minus x plus 3. Okay, so the same thing. Can you try to do square here? No, you can't. Why is that? Because you never know that what is that inside here. So when you try to solve it, you try to square it already, meaning that 10 minus anything, then when you square it, then no matter it's positive or negative, you are going to get the positive side only. So since you cannot sure that whether your left hand side or your right hand side, you cannot confirm that your right hand side is a positive number, so you cannot do squaring. Okay, so that's why for this question we are going to use the definition method to continue it. So this will be much more complicated because you have two sides, and because of you do not know which side is positive, which side is negative, so that's why we need to solve it one by one. Okay, let's try to eliminate the modulus for this side first, because you remember normally we only can do modulus if we have one side contained of only modulus. So we try to assume that this is the normal number that we have, so this is the modulus part that we have. So I will have one part is x plus 3 equals to 10 minus x plus 5. This is a positive one. The negative one, I have x plus 3 equals to negative 10 minus x plus 3. Okay, so I have one positive and one negative, and after that only I continue. So I'll continue to solve it. So maybe I'll switch this around. X plus, sorry, this is 5. Why do I write 3? Okay, so I'll continue it. So x plus 5 equals to, when I shift it here, then it will become 7 minus x. Okay, so how should I continue? Now I have the other modulus again, then I can continue to do the same process again, meaning I'm going to split it again. So it will be x plus 5 equals to 7 minus x, or x plus 5 equals to negative 7 over x. Okay, then I'll continue to solve. X equals to negative 2, x equals to negative 1. Then the other one, x plus 5 equals to x minus 7. Then what you can realize is x minus x, you get 0, then it will be equal to negative 12. So you know that this is definitely a wrong one, so no solution. Okay, so even after you get this, you still need to check. Then you do your checking. So negative 1 plus 3 plus negative 1 plus 5 equals to 10. Is that correct? So here you get 1, 2, do I do something wrong? Negative 1 plus 3 you get 2, and then you plus 4 you get only 6. Negative, hold on. Oh, I'm sorry, this is positive. Okay, so 1 plus, so 4 plus 6 I get 10, which is correct. Okay, then don't forget about this part. I'm going to write it here. Okay, so it's the same thing. So x plus 3 equals to negative 10 plus modulus x plus 5. So I will have modulus x plus 5 equals to x plus 13. Then the same thing, I'll need to split it into 2 as well. So x plus 5 equals to x plus 13, and the other one is x plus 5 equals to negative x plus 13. Okay, then 0 equals to 8. This one no solution as well. So the other one will be x, then you get 2x here equals to negative, so negative 18, then you get x equals to negative 9. Okay, so the same thing, you will need to check it. Can you try to write it yourself? I don't have enough space here. Okay, so check yourself, then you should be able to get a true one as well. So that's why your answer, you will have x equals to negative 9 and x equals to 1. Okay, alright, so this will be our first video. Then for the second video, we are going to look at the modulus inequality. So we already learned how to draw a graph, how to draw a graph of modulus function. Then after that, we learn how to solve a modulus equation. So in this part, we are going to see how do we solve a modulus inequality. Okay, so let's try to look at some explanation first. Okay, so let's start with what is written in your notes. Okay, so I'll try to explain it. So please try to not memorize it, but to understand like why. Okay, so if I have something that is modulus A lesser than B, what does that mean? Okay, so let me try to illustrate you in a way that you can understand it better. So let's say if I try to change it to modulus x lesser than 2. Okay, so what does that mean? You remember the distance or the magnitude illustration that we used in first lesson, right? If I'm going to draw a graph, then this is how it will look like. This is x. So magnitude of x lesser than 3, meaning that the point should have a distance that is lesser than 2, correct? So I mean, obviously you know that if this is 2, then it's definitely this is going to be x. This is going to be 2. Okay, then definitely this is the area that you can accept, correct? Because all this area, any point on this area will give you a number that is lesser than 2, meaning like 1 of course have a magnitude that is lesser than 2. 0.5 will give you a magnitude of 2 as lesser than 2 as well. Okay, do you have any other side? Yes, because we are talking about the magnitude, meaning any distance between the point and the center is 2. So it can be this side also, which is negative 2 here. So meaning anything within this point will give you a distance that is lesser than 2 as well. So for modulus x lesser than 0, it means that what you can accept for your x is basically negative 2 to 2. Any number within this range, after I put in the modulus and I solve it, I should be able to get a number that is lesser than 2. I mean, of course, you know that modulus wouldn't be a negative number. So meaning that, like for example, negative 0.5. So after I put inside the modulus, I get 0.5, which is lesser than 2. Okay, so you will see modulus x lesser than 2, this is what we get. Alright, so now let's try to change it back to this. If I have this, then what do I get? It's basically equals to, so let's see, my a is my x, right? So a will be greater than negative b smaller than b. Okay, so meaning that any modulus a lesser than b, meaning that I would be able to write it in this form to solve it. Okay, now how about greater than? Modulus a greater than b is the same thing without the equal sign, so I wouldn't want to write it again. Okay, it means the same thing. Okay, so let's say I try to do it like x greater than 2. Okay, so I have a number line here as well, so 0. So since we already know that the distance is 2, so let me just write it like this. Okay, where is the point that will give you a distance more than 2? So it will be anything after 2, correct? So the same thing here, it will be anything after negative 2. So any point before negative 2 or after 2 is going to give you a distance that is greater than 2. So what do you have here? It should be x lesser than negative 2 and x greater than or equal to 2. Okay, so let's do the same thing, change it back. Then what do you see? So you get a lesser than negative b and a greater than b. Okay, so this is how these two formula or these two concept coming in. Okay, so we are going to use that method to solve our question. Okay, so let's try to look at number 2a. Okay, so 2a, modulus 2x minus 5 lesser than 3. Okay, so since you have less than, so that's why we can try to do it in a way that, so if modulus lesser than 3, meaning that it can be 2x minus 5, okay, either this thing greater than negative 3 or smaller than 3. So in this range, they will give you a number that is lesser than. So you can just try to imagine like the distance between, so you can try to imagine if you have, this is the center. So I do not know what is 2x minus 1, but I know that the distance, it should be lesser than 3. So it can be like here, and it can be like here, and the thing that you want is definitely in between, because you want lesser than 3. So this is how you get to this one. Okay, then after that, let's continue to solve it. So 2x, let me try to write every step down. So 3, negative 3. So when you move it, you get plus 5. The same thing, you must move it to both sides. So plus 5. Then you will get 2x, 2, and then 8. So x, 1, 4. Alright, so this will be our answer. So meaning that if I have an x that is in between 1 to 4, they will always give me a value that is lesser than 3 when I solve it with modulus. Okay, now let's try to do this with graph. So I'm just going to show you AC with graph, then it's just like an illustration for you and some practice for you for the graph lah. So we wouldn't need to like do it again in another questions. Okay, so let's do the same thing. So meaning that what you need to do, you need to do two graphs. So this is method 2. I'm going to do it here. Okay, so y will be equals to modulus 2x minus 5. So how are you going to draw that? So maybe we just draw the normal one first. So meaning we use the reflection. So y equals to 2x minus 5. So you will have when x equals to 0, y equals to negative 5. So the intercept will be in the middle. So let's not try to do that. Then we try to do the other one. Let's say if I have x equals to 3, then I should get y equals to 1. Okay, so let's try to draw it and see. Alright, so I have a graph. Okay, then I will try to, sorry, give me a minute. Okay, alright, so let's continue. 1, 2, 3, 1, 2, 3, 4, 5. I'll need up to here. So maybe I'll cut it over here. 1, 2, 3, 4, 5 is enough. Yeah, sorry, I want to squeeze everything into one paper. Okay, so I have 1, 2, 3, 1, 2, 3, 4, 5. It's my intercept here. Then I have x equals to 3, y equals to 1. X equals to 3, y equals to 1. Then it should be somewhere here. Okay, then I will try to draw it. So since that you know that anything under is just like a reference for you, so you are going to put it in. Okay, so after you did that, then you know that it's going to be a reflection, right? So that's why negative 5 here will actually reflect to 5. So 1, 2, 3, 4, 5. So it's going to be like 5 here. Okay, then you try to reflect it at the point that it touches your y-axis. Sorry for the alarm. Yeah, you might need to wait for a while for it to go. Okay, so this is what we have drawn for y equals to modulus 2x minus 5. Okay. Okay, so now let's try to draw the other line, which is y equals to 3. So y equals to 3 is over here. Okay, so I hope that you can see the two lines. Okay, so you want to get the area that is modulus 2x minus 5 lesser than 3, meaning that you want the area that this graph is less than 3. You get the idea? So this is the line, right? And this is the other line. So meaning that the modulus line should be lesser than 3. Where is it? Then it will be at this area. Okay, I only try to draw it like in this way so you can. Okay, only at this point your modulus line is less than the y plus 3 line. So over here you can see that this line is above this line, so every reading that you have here is of course going to be greater than 3. So here also, any reading that you have over here, the y will be always at 3. So meaning only at this line, you have 3 more than the modulus, which is also the modulus less than the 3. So what is the range that you want? So it's basically what you can see here lah. So what is this? This is 1. What is this? And this is 4. So this is basically your answer, 1, 4. Okay, you get the exactly same thing. I'm sorry, without equal to. Okay, so the sign depends on the question itself. So the graph, you just do it like normal. So you check like if modulus lesser than 3, meaning that when you draw the line, then you should be able to see where is the point that you have the modulus graph below the other line that you want to find. So this is by using the graphical way. Okay, alright, so let's move on to the next question. Okay, so 2x plus 3 greater than 7. So, okay, so let's do the same thing. So you can imagine that this is your number line, and since this is 7, so you know that negative 7 and 7. So since you want more than, so you know that you are going to find this part and you are going to find this part. Okay, so you can straight away find out your two inequality, which is it will be 2x plus 3 this side, so lesser or equals to negative 7, or 2x plus 3 greater or equal to 7. Okay, then you can continue. 2x lesser than negative 10, so x lesser than negative 5. So 2x greater than 4, x greater than 2. Okay, so your answer will be x lesser than negative 5 or x greater than 2. Alright, so yeah, I think it's quite easy, right? So basically you know that how to draw this, how to write in inequality, then you should be able to solve it already. So this is the same thing you can try to draw in your graph as well. So after you draw it, then you check for the idea for your modulus graph is higher than the y equals to 7 line, then you will be able to get the exactly same answer as well. Okay, so I'm not going to show here, it's like very long for the video today, like plus the lesson 1. Okay, so let me try to go to C. Okay, so C, you have two modulus, 2x minus 1 greater than 3 minus x. Okay, you have some problem in this. So you remember last time we said that this question you can either do by squaring both sides, or you can try to do like understanding which side is going to be negative, positive. Okay, because what happened here is like previously, we only have the idea of positive or negative and is equal to. So for example, let me grab the paper that we did. Okay, let's say this is the idea. So we have all this, like since it's equals to, so actually it didn't make any difference whether you take this one or this one, or you take this one or this one, because it's equal to. But then you imagine now when you try to change everything into like greater sign, is there any changes that happen? Yes, because whether it's positive or negative, when you try to solve it, when you divide or multiply something that is negative, it's going to affect your sign. It's going to affect your sign, because when you divide by a negative number, you are going to change the sign, right? So since you do not know whether your left side or right side is negative, it's very hard for us to use this method to do, because you cannot really decide whether you want to put at negative. So the idea is like, it's different. Okay, when I write x equals to -3 and when I write negative x equals to 3, this is the same thing, right? But is it the same thing if I write x greater than -3 and when I write negative x greater than 3? Are they means the same thing? No, it's a different thing, because when I divide by here, I'm going to change this sign. It will become x lesser than -3 now. So since there is a difference for us to do this, it's very hard for us to use definition to do this. So that's why you have only one approach, which is to use squaring. So how do you do squaring? So since we already know that this both side is going to be positive, right? So meaning that when modulus A equals to modulus B, it is not going to affect it when I try to do this. So meaning if I have modulus A greater or equals to B, since I know that 2 modulus of this is a positive number already, meaning when I try to square it, I wouldn't get a risk that I will need to change the sign, because I know that definitely anything out of modulus give me a positive. But then you cannot like use the squaring method in the part that you know that maybe you are going to get a negative answer lah. Okay, but for this one you can. So for anything that you have both side modulus, then you can always do like this as well. Okay, so it's very easy for number C. Basically you just try to square both sides, okay, without changing the sign. Okay, so 4x squared minus 4x plus 1 greater than 9 minus 6x plus x squared. So 3x squared plus 2x minus 8 greater than 0. Okay, then you would be able to continue to solve it by factorization. So 3x minus 4x plus 2 greater than 0. Then you can try to draw the graph as usual. So -2, 4 over 3 greater than 0. So it should be this part and this part. Okay, so what is your x? Your x will be lesser or equals to -2 or x greater or equals to 4 over 3. Okay, so this is the answer. Okay, so maybe let us try to do the very last question on graph before we move on for the last questions. Okay, so let's try to do this question on graph as well. Alright, so let me try to write everything over here. So I have, this is what I want to solve, 2x minus 1 greater than x minus 3. Sorry, 3 minus x. Okay, so let's try to use the definition way to do this maybe. Okay, so I'm going to draw the first line, which is 2x minus 1. So I know that I will have two parts here, which is the first one is I might have 2x minus 1 if 2x minus 1 is greater than 0, which means x will need to be greater than 1 over 2. Okay, or like equal to. Okay, so the same thing, I will have negative 2x minus 1, which is basically negative 2x plus 1 if my 2x minus 1 is lesser than 0, which means my x is smaller than 1 over 2. Okay, so meaning that I will need to actually, so you see every time you have a reflection, right? So meaning that you have actually two lines. So one line is for x greater than 3 and the greater than 1 over 2, and the other line is for x smaller than 1 over 2. Okay, so now try to do the other one, which I have x minus 3. So I get the exactly two thing as well. So first one is x minus 3 minus x. if 3 minus x is a positive value, which means x should be lesser than 3. So the other one is negative 3 minus x, which is x minus 3, if 3 minus x is negative. So meaning x should be greater than 3. Okay, so now we are going to draw it in the graph. Okay, so 1, 2, 3, 4, 5. Okay, so maybe I'll put it over here. Okay, so now let's look at the graph. I'm going to use different colors so you can see it better. Okay, so 2x minus, so for anything that you have x greater or equals to 1 over 2, you are going to draw the line 2x minus 1. So you know that the reflection part will be at the line of x equals to 1 over 2. Okay, so let's start with greater than, meaning that you are going to draw this part. So it's going to be passes through intersect negative 1. So you know that you are not going to draw at the negative side, but this is like a reference point for you to draw the line. So you are not going to draw it pass by the x-axis. So you need the other point over here so we can get a better idea. So let's say if I substitute 2, then I should be getting a 4. So I substitute 2, I get a 4. Okay, so I will get when I substitute 2, I'll get a 3. I substitute 2, then I'll be able to get 3, so which means like over here. So if I substitute like 4, then I will be able to get a 7. 1, 2, 3, 4, 5, 6, 7. So it's like somewhere here lah. Okay, so I'm going to draw the line. Okay, so how about when x is lesser than 1 over 2, then I will need to draw a line that is negative 2x plus 1, so it will passes through 1 here. So maybe let's try to do the other line so it will be much more better for us. So let's say if I substitute negative 2, then I will get 5. Okay, so negative 2, then I will get 5. 1, 2, 3, 4, 5, so maybe somewhere here. Okay, so this will be our reflection. Alright, okay, so let's try to do the other one. So this is 1 over 2, and this is basically for y equals to 2x minus 1. Okay, so let's try to do the other one, which for 3 minus x. So the critical point is at 3, so meaning it's like here. Okay, anything that is greater than 3, I'm going to draw x minus 3. So I know that the reference point, the intercept will be over here. So if it's equals to 6, then I'm going to get 3. So maybe it's like here. Then I'm going to connect them together. 1, 2, 3. So maybe it's like here. Okay, then now I'll draw the other part. When x is lesser than 3, I'm going to draw 3 minus x. So the intercept is at 3 here. So let me try to use the other line as well. So if x equals to, let's say x equals to 5, then x equals to 5, then I will be able to get 2. X equals to, no, I can't, I will use up here. X lesser than, okay, if x equals to 5, then I will be able to get negative 2. So x equals to 5, I'll use up here. Let's use a negative. Okay, negative 3. If I put negative 3, then I'll be able to get 6. So 1, 2, 3, 4, 5, 6. So it's here. Okay, then I'm going to connect them together. Alright, so this is your graph for x equals to 3 minus x. Okay, so after you have this graph, then you see what is the point that you actually want to find. You want to find when 2x minus 1 is greater than 3 minus x. What does that mean? So 2x minus 1 is the orange color one, then 3 minus x is the chocolate color one. So meaning that what do we want is actually the part that the orange color is above the brown color. So meaning that it will be in the range of here. So let me try to cut it. So it's like over here and here. So you can definitely see that for anything that is within this range, right, the brown color is more than the orange color. So we are looking at it is like the x value, because what we are looking at is the value of the whole thing is like greater than the other. So that's why for anything within this range, the brown color is above the orange color. So what we want is the orange color greater than the brown color, right? So meaning it will be the part that is outside. So I think this one is quite obvious that you can see it's -2. But please make sure that your graph is like accurate. Like if not, then you need to find the intersection. So for like this, right, it's very hard for us to read because it's like somewhere in the middle. So what do we need to do? We need to solve it simultaneously. So for the orange color, anything that is greater than 1/2, actually we are drawing y equals to -2x plus 1 for this line. So now the intersection for this line is over here. So x lesser than 3, we are using 3 minus x. So y equals to 3 minus x. So you solve it simultaneously. -2x plus 1 equals to 3 minus x. So this is how I get to x will be equals to I will be able to get 3x equals to 3x. Hold on. -2, did I write something wrong? Lesser than, sorry, I'm looking at this one, so it should be x greater than 3, so it's 2x minus 1. Sorry, I repeat again, the intersection is here. So I'm looking at from here above, so that's why it should be x greater than 1/2, so I'm going to get this one instead of this one. Okay, so let's check again. This is lesser than 3, so it should be 3 minus x. Okay, this is correct. Okay, so let me write again lah. Okay, so 2x minus 1 will be equals to 3 minus x. So when I move it, then I get 3x will be equals to 4. So x will be equals to 4/3, which is basically what this is. Okay, so what is the answer? Then it will be anything my x lesser or equal to -2. I will get the orange color above the brown color. Then the x greater than or equals to 4/3, which is like over this part, I get the orange color above the brown color as well. So this is how do we use a graphical way to solve it. Okay. Alright, but of course, if the question didn't like ask you to use graphical or algebra, then like obviously you will actually try to go to this way instead of doing this, right? Yeah, so this is just an idea for you to know how to draw the graph, and if they ask you to use graphical way to do it, then how can you do that? Okay. Alright, so let's move on to the very last questions. Okay, so D. X minus 1 greater than 2x minus 4. Okay, so I purposely put in this here because I want to show you that like this one, can you use squaring to do this? Okay, so obviously you have 2 modulus, right? So as the explanation just now, you know that you cannot use definition to do this question because it's going to be different for the sign. So how can you do that? Because this one you are not having modulus only. Outside the modulus you have something. But you remember just now for f, right? This is 10 minus. But this one is times. So if you have something minus, then obviously you do not know that whether you will get a positive or a negative. But if it's times, is that going to affect that? So you know that anything out of the modulus, you are getting a positive number, correct? So when a positive number times with a positive number, you will always get a positive number as well. So that's why this question, you can do squaring. So meaning that you can do x minus 1 square greater than the whole thing, you just square it. Okay, so the idea is no matter this is positive or negative, since that is in a modulus, right? So you know that you are definitely getting a positive. So that number, when you use it to square, then you get the exactly same idea as you are changing the negative to positive already. Since you do not have the chance to have negative, right? So you just square it. Okay, so x squared minus 2x plus 1 will be greater than 4. Then you just square this first. So x squared minus 8x plus 16. So x squared minus 2x plus 1 greater than 4x squared minus 32x plus 64. Okay, then you can move it. 3x squared, I have minus 30x plus 63 lesser than 0. I'm moving the whole thing over here. Okay, then x squared minus 10x plus 21 lesser than 0. So x minus 7, x minus 3 lesser than 0. Okay, so I have this part. This is 3, 7. So your x should be greater than 3 and lesser than 7. Alright, so those are the things that we learned. So please make sure that you go through the example and so on, and make sure that you can understand everything. So have a good semester break. So I hope that you take this good time to like do your revision and finish all your assignment and so on. Alright, thank you.